Hey guys, the last time in 7.6 we talked about how to graph the functions of sine and cosine, right? And from there, I promise you guys I'm going to show you guys another way to graph either sine and cosine by the transformation of function graphs. This right here, like the name of it. So the last time we have a function, for example, for my part, I have like y equals to negative 2 psi of x, right? And I told you guys there are a table of like, you have to get the new x value and also the new y values for like graphing the 5 points from the quadrant angles. And from there, we're gonna connect all the points together and then we're gonna graph them, okay? This time, let me show you another technique to do that, okay? So first of all, here, let me grab the xy coordinate. And sorry in advance for the space. I don't know how to make like a new page function in there, sorry. Okay, so this time, originally, I'm gonna take the graph of y equal to psi of x. And I'm gonna call this one the parent function. If you notice, the pink function compared to the red function, the pink one, it doesn't have any number in front of it, right? It just have the name psi, right? So in here, again, we're gonna use the 5 old points from the 4 quadrant angles. So we're gonna get like 0, 0 up here, and then at pi over 2, we're gonna have 1, and then so on, right? Like you can see the pattern there. And if you connect them, you will have like a psi function. And I told you guys, like this one is just like for the first cycle, right? If you want, you can extend the graph on both sides, the left hand side and the right hand side of the pink function. And then you will see that this function goes periodically, okay? As for the red function right here, the only difference between the red and the pink functions is the negative 2, right? So what I'm gonna do is that I'm gonna take care of the 2 first. I'm gonna extend each of the 5 points in here by 2. I'm gonna stretch them out vertically, and after that, let me put it in orange. For the negative, I'm gonna flip all the points like upside down, okay? And then we're gonna have the new graph, okay? So let me stretch it out first. Okay, first of all, let me erase this one and make a better graph because I think that I might need more points, okay? So let me just put this one in pink for the original graph. So I'm gonna have like a y in here and an x in here, and then again it's gonna look like this, right? And then for the red one, for the one that has just like the 2, I'm gonna extend it, right? I'm gonna expand it like this. So as you can see, like the y part in here, because it's originally at 0, so 0 times 2, it doesn't change much. It still stays at 0, right? But then originally this point here, it has the y coordinate as 1. So now if you multiply it by 2, you're gonna get up to 2, right? And with the similar logic, you can do 0 up here, 0 in here, and then this one will be like negative 2. Okay? And then lastly, to take care of the negative side in here, I'm gonna flip everything upside down. So this one in here, the y part is 0. I cannot like make a 0 negative because like positive 0 and negative 0 are the same thing. So I'm gonna keep that point, I'm gonna keep this point, and I'm gonna keep this point, right? But instead of having like negative 2 up here, I'm gonna have negative 2 down here. And instead of having like a negative 2 at the x part equals to like 3 pi over 2, I'm gonna have 2 up here. So at the end, I'm just gonna go ahead and connect all the points together. And this one in here is the function, is the graph of the function y equals to negative 2 psi of x. Okay? So again, if you want, you can compare it to the function that we had in page 3 in section 7.6. They should be the same thing, right? But there are like 2 different techniques to do that. So in order to like interpret the meaning of the numbers in here, well, we have 2 numbers, right? Like we have 2 parts in here. The first part is about a 2 and the second part is about a negative, right? So the 2 in here, if you have like a number in front of your function, we're talking about this case in here. And in here, since k is 2 and 2 is bigger than 1, we have a vertical stretch, okay? Like I didn't mean to cross it. So we're gonna have like a vertical stretch by a unit of 2 or like by a factor of 2, okay? Like if I ask you in the exam 1, if I ask you like to compare the orange function to the pink function, you're gonna tell me that the orange function can be obtained by stretching the pink function by a factor of 2 first, And then for the negative, because it's like in front of the function again, so we're talking about this case right here, that means that we're gonna reflect the red function over the x-axis. Okay, so this one is kept like straightforward by like whatever numbers that you have like either inside or outside of the function. So just be aware that you have like 8 cases in here. Okay, and then I'm not gonna ask you guys to memorize everything on this page because, you know, like all my class, as long as you have it printed or like in front of you guys, in front of the before the test come, that would do it for me. Okay, and just a little bit of like reminder from the 7.6. We also talk about the domain range of each function of sine and cosine, right? And they share like the domain range. So for the domain, you can take any number. Okay, so x can be anything. X could take like positive number, negative number, and a 0 also. Okay, but as for the range, it has to be between -1 and 1 inclusively. Okay, for the like original psi function. Okay, this one I'm not talking about like the new function, because as you can see in here, like if you talk about the orange function in here, the range of it is actually from -2 to 2, right? Because it has the a number equals to -2, and that means that we have to take that a number, multiply to -1 and 1 in here, and for each of them we're gonna get like -1 and 2. That's why the range in here equals to -2 to 2, not -1 to 1 anymore, because we actually have something in front of sine. Okay, but the domain in here has no like effect whatsoever to the function. Even if you have a new function, your domain will stay the same as all real number, right? Because you cannot go any like broader than all real numbers. Okay, and lastly, in terms of like amplitude and asymptote, sine and cosine functions have amplitude of 1. Like this one also, I'm talking about the original psi function, right? Because if you talked about like the orange function right here, the amplitude of it is actually 2, right? Because we're gonna take the absolute value of a to get 2, and again, amplitude, it has to be a positive number always. Okay, amplitude cannot be negative at all. Okay, so keep in mind that amplitude, it has to be a positive number. Okay, and lastly, sine and cosine doesn't have any asymptote, and if you guys wonder what asymptotes are, I'm gonna show you guys in a minute what asymptotes are. Okay, and that's actually the reason why we have like 6 functions, but then I'm talking about like sine and cosine first. But then in 7.7, I'm going to talk about the rest of them, like tangent, cotangent, cosecant, and secant, because these 4 functions, they actually have something called asymptote. Okay, so let's talk about the first page in here. Graphs of tangent and cotangent functions. Well, so just like the last time, right, we're going to use like 5 points, but then if you notice, these 5 points are actually not the 4 quadrantal angles anymore. Okay, so I noticed that tangent is an odd function and cotangent is also an odd function. That's why if I like take something like center to them, I can reflect them to get like the value of the outer side, right? So it's kind of like hard to explain why you have to go with this number in here. In fact, you can go with like other numbers of x values, but to my experience, let's just be aware that you're going to use the numbers of like, you know, like -90, -45, 0, reflect them all over in positive numbers, so you're going to have 95 and 90 degrees. Okay, so for now I have like no good explanation why we have to do this, but then it will explain itself if you see the graph. Okay, so notice that if you plug tangent of 90 degrees or -90 degrees into the calculator, it will show you error, right? That is because if you notice, sine of -π/2 is 1, but then cosine of -π/2 is 0, right? And if you were to get tangent of -90, you're gonna get -1 divided by 0, and because we have a 0 on the bottom, this is like undefined. That's why we have the word d and e in there. Okay, similarly, this one we're gonna have the case of 1 divided by 0. That's why on the calculator will show error, and hence it's undefined. Okay, and as for the 3 middle values in here, if you plug them into the calculator, you will get a -1 in here, 0 in here, and 1 in here. Okay, and if you want, you can recall the table that I show you guys, like with the tricks you remember, with like counting number from 1 to 3, and then 3 to 1 and backward, and then divide using like, you know, like psi over cosine, the quotient identities from tangent. So anyways, anyhow, if you want to use a calculator, I'm not gonna like judge you on that one. So technically we're gonna have all of that, and then in places that we have like the word undefined, we're gonna have asymptote. Okay, we're gonna have a vertical asymptote to be more precise. And what does it mean? Well, let's actually do the easy one first, right? So at the point of okay, so let's plot this one out first. So we're gonna have negative 4 pi over 4 and negative 1, right? So that is right here. Wait, can do better than that. I can do better than that. There, well, close enough, right? And then 0, 0, I have this one in here, and then pi over 4 and 1, I have this one in here. Okay, so a special feature in here is that it's gonna look like an Egyptian dance. And what does it mean? It means like, you know, just imagine you're gonna have like, you know, like 2 arms, and then if you want to do the Egyptian dance, one hand would be like up here like this, and the other hand would be like down here, right? I'm gonna show you guys. Okay, here, let me show you guys a picture of the Egyptian dance. This is what I'm talking about. Like one function, like one branch of tension is gonna look like that, and the other one is gonna look like that. But in reality, they actually connected, right? And then on the 2 hand sides, we're gonna have like the thing we call them vertical asymptotes. Vertical because, as you can see, they are vertical, right? And then asymptotes because at those dashed lines in there, we have no y values. Okay, so let's go back in our page. This one right here. So at pi over 2 and negative pi over 2 right here, we're gonna have the 2 asymptotes. That means that you can extend the lines. Okay, let me draw like a better line here for you guys. So we have 3 points, right? And make sure you don't connect them as a straight line, right? It does look like a straight line between the 3 points, but don't do that way, okay? And remember, you cannot like bend it this way, okay? You have to bend it the other way around. So it's gonna look like this, and the other one, try to bend it like toward the asymptote, so it's gonna look like this, okay? So that's what it means by Egyptian dance. And then from both sides, you can extend the line no matter where you want to. But make sure you don't ever cross the vertical asymptotes, okay? So that's the special thing about tangent. And for cotangent, we're gonna have like another, like, you know, like 5 points in here. I'm sorry for like asking you guys to remember like 3 different sets of 5 points for the x value. But as you can see for tangent in here, because it's symmetric over the point 0, 0, that's why I go for 0 as a center, and from there I just choose like 2 random points from the 45 and then the 90, and I chose the 90 like purposely because I know that at 90 and negative 90 we're gonna have asymptotes, okay? The negative pi over 4 and pi over 4, they are there because they make like nice number. As you can see, they make negative 1 and 1, right? That's why I go with this values of like x values, okay? But then besides that, I have no good reasons. So same things in here. If you put like these value into the cotangent function, you will see that let me grab my calculator real quick. We're gonna have like 1 in here, 0 and negative 1, okay? So this one again, wherever we have like does not define, they are our VA or vertical asymptotes, okay? So we're gonna have 1 vertical asymptote at 0 is vertical and it's in dashed line for asymptote. We have 1 more at pi, okay? And then let's do the center first. So at pi over 2 we have 0 right here. At pi over 4 we have 1, which is like up here. And then at pi over 4, 3 pi over 4 we have negative 1, which is down here. So again, I'm gonna connect them in such a way that they will go like tangent to the asymptote. Okay, so they will be like curvy like this, and you're gonna put the 2 arrows in here to show that they can go to whenever you want. Okay, so those are like the functions of them, right? And then just like the idea of extend the function to both sides, like cosine and psi, you can also extend it, right? So if you copy and paste this junk to the right hand side, you will see that the next asymptote, it is pi away, right? So it should be right here. And then if you copy and paste, the function is gonna look like this ish. And then this one, same thing. If you were to have like another mark in here, it's gonna look like this. Okay, and same thing with this one. So these are all like periodic functions, right? And for the cotangent functions, if you want, you can like copy and make and paste it more like to the left and to the right hand side. So you can have something that looks like this, and same goes for the other side. It's gonna look like this. Okay, so now let's talk about the max and min midline like before. Okay, max and min we have none, right? Because like it doesn't, as you can see for each of the like part in there, they doesn't reach to like a specific like maximum or minimum, right? They go all the way to infinity up here, and they go down all the way to negative infinity down here. And same goes for cotangent, right? So that means that we have no maximum and no minimum. Okay, midline, we just have like one midline point, right? And if you want, let me draw the midline here really quick. Is the one that passing through the center, right? And I told you guys the middle one is always the center. So here, let me just like draw it in pink so you guys can know that they are the centers. Okay, so in here, the midline point, it will be 0, 0 for tangent, but for cotangent, it's gonna be pi over 2 and 0. Okay, and then lastly, I told you guys before that we're gonna have something called D and E doesn't exist for the y value, because tangent and cotangent, it has the denominator, right? And whenever we have 0 on the denominator, that means that we're gonna have vertical asymptotes. Okay, so for each of the cycle in here, we're gonna have 2 vertical asymptotes. Okay, for tensions, it's gonna be negative pi over 2 and pi over 2, but for cotangent, it's gonna be 0 and pi. Okay, and then special features is like sine and cosine. Tangent is like the next like update of psi, if you want to think about it that way, because it's passing through the origin, while cotangent is the next update version of cosine because it misses the origin. Okay, so just so like a little tip so you guys can remember which one is like the old version of which. Cotangent and cosine, they have like the word co in there, right? And they all start with a C, right? So the C functions, they all should behavior like the same way ish. And in the second, you will see that cosecant and secant, they will have like similar features to what we just learned in this page. Okay, and the very last thing that I haven't talked about in here is about the domain and range and the amplitude, right? The amplitude in here is obvious that we have no like certain limit, right? We have no bound for each of the function or each of the cycle in here. So that means that we're not gonna have any amplitude in here. It doesn't have anything to tame the functions in here. It goes to both sides, right? That means that amplitude, we have none. Okay, for both tangent and cotangent. Okay, another trick is that if you have a vertical asymptote, that means like obviously you're not gonna have an amplitude. Okay, because vertical asymptote, it means that your graph extended to like both sides, like to the left hand side and to the right hand side. That means that it has no bound, right? And because it has no bound, it has no amplitude. Okay, last thing, domain range. Let me change it to blue. So the domain in here, as you notice, it can take any value instead, but it cannot take the value of, you know, like the asymptotes in here. And if you notice, there's a general like pattern to the asymptotes. They actually the odd integer multiples of pi over 2. Okay, so if you notice, this one right here is negative 90. This one in here is 90, right? And the next one in here is 270. The next one in here, okay, this is where I really hate math. Let me think. So this one is like 5 pi over 2, so it's like 9 times. So, okay, 450 degrees if you want to calculate it out. And on this one in here, we're gonna get negative 270 degrees. Okay, and if you notice, this one is a multiple of pi over 2, right? By negative 1, because 90 times negative 1, you're gonna get negative 90. 90 times 1, you get 90, right? 90 times 3, you're gonna get 270, and 90 times 5, you're gonna get 450, right? And if you notice, like all of the numbers that you just multiply by, they are all odd integers, right? That's why I'm saying that the domain in here, it can take any value except for the odd integer multiples of pi over 2. Okay, and then similarly for cotangent, we're gonna have the domain, it can take any value except for, you know, like those vertical asymptotes right there. If you want, let's put them into values, right? So we're gonna have a 0 in here. In here we're gonna have a pi, and in here, if you notice, that's a 2 pi, right? And in here it's gonna be like a negative pi. And if you want to extend it more to the right hand side, it's going to be like 3 pi, 4 pi, 5 pi, and so on, right? And if you want to extend it to the left hand side, you're going to get negative 2 pi, negative 3 pi, and so on, right? So in here, it can take any value except for the integer multiple of pi. So here, let me circle the word integer multiple of pi. That means that you cannot have 0 pi itself, 2 pi, negative 3 pi, 5 pi, negative 4 pi, anything that has to do with pi, no, okay? As for the range, it covers pretty much the whole like y-axis, right? So for the range in here, it takes everything. Here, let me highlight it because there's like too much in this page already. So the range in here, it covers all real numbers, right? And same goes for cotangent, it covers all the numbers in here. So it doesn't like miss anything, okay? So now, just like a really quick notice before we move on. Know that tangent and cofunction and cotangent, let me clear this one down a little bit. Okay, much cleaner, right? So know that tangent and cotangent are also periodic functions, right? Just like cosine and sine, they repeat it after like certain points, right? But the period is in here is actually pi, okay? So here's a big difference, okay? For sine and cosine, the period of them is 2 pi, but then for tangent and cotangent, the period of them is actually pi. So make sure you got them down, okay? Because on the test, I'm gonna ask you something like, is the period of tangent like 2 pi? And then you have to tell me no, because it's period of tangent or cotangent is actually just pi, not 2 pi, okay? So in here, they repeat everything up to pi. So as you can see, like each of the gap in here, like each of the chunk in here, it takes pi, right? Like each of them, they all take pi. And in here, like between one cycle, it's just pi, okay? Not just like sine and cosine where it takes like 2 pi. In here, one cycle only takes pi, okay? And let's move on to the first example in here. So how to graph them? Well, again, you can use like 2 methods. The first one is by table. Like this is the easier one when you just have to like copy the table in here and then plug in the numbers and then plot out the points and then connect them. And there you go. There's a graph, right? The harder way, well, you have to remember the behavior, the graph of the original functions, which we already talked about in page 2, the last page. And then you have to like move them around, like move them up, down, like shift them, stretch them, or like compress them, or even like reflect them based on like whatever numbers you have on the function on the transformation table, okay? So let me talk about the easier way in here. So again, if you notice, we use like the same 5 points that we have for tangent from the last page in here. And in here, you're gonna get like, you're gonna see them like 5 values again, right? And in here, we're gonna have like some D and E for like doesn't exist. And at there, we're gonna have VA for like vertical asymptotes, right? And the rules are the same. If you have like A in here, you're gonna multiply them, right? But if you notice, we actually have like have a B, right? An extra number. So what you're gonna do is that it tells us to add B, right? So we're gonna add B to the Y part, okay? So make sure that A and B, because they are outside of tangent, that means they are meant for Y, okay? And because W in here is like inside tangent, that means it's meant for X, okay? So in here, to get the new X, we're gonna do the same thing. X divided by W, okay? So it's pretty much what we have from like sine, cosine graphing, like table. So in here, I'm gonna do it really quick in here. So for the new X, I'm gonna, well, first of all, let's identify the A, W, and B, right? So in here, I have my A equals to -4. My W equals to 3, and my B in here, it equals to 1, okay? So then I'm gonna use like the set of rules that I had before. For the X's, I'm gonna take it and divide it by 3 because my omega is 3. For the Y's, I'm gonna multiply it by A, which is -4, and then after that, I add it by 1, okay? So this is like the new rules to get the new Y's, okay? So now, let's do it really quick. X will get the X, right? So each of them, I'm gonna divide it by 3. If you put it into the calculator, this one will give you -pi/6. This one is -pi/12. This one is 0 because 0 divided by 3 is 0, right? And then this one, if you're lazy, you just kind of like flip them. Like these in here are symmetric to each other, and these in here are symmetric to each other, okay? And let's talk about the points, right? So V in here, it makes sense because we have like, we doesn't have like any Y values, right? So that means that we're gonna have VA in there. And if you want to put them into like points, here, let me just do it really quick. Okay, so the points in here, it goes like negative pi over 6, comma, VA, because we don't have like a Y value, right? And then here I'm gonna get like pi over 6, comma, VA for the Y part. Okay, for the point here, I'm gonna get something like negative pi over 12, and I'm gonna wait to get my Y values in a minute. And then here I'm gonna get 0 and waiting for my Y, and then pi over 12, and again waiting for the Y, right? So now let me get rid of something in here to get like more space. All right, so we have the setup rule in here. So we're gonna grab each of the OY and then multiply it by -4 and then +1, right? Originally we don't have any Y value in here, so like if you grab it and multiply it by -4, if you do anything to it, it's not going to give you anything because we don't even have a number to start with, right? Same thing goes with this one. But now we do have a number, right? So we're going to do -1 times -4, which is 4, and then +1, that means we have a 5 in here. 0 times -4, which is 0, +1 is 1. 1 times -4, that is -4, +1, that is -3. And let's fill out the Y values that we had earlier. So this is 5, this is 1, and this is -3. Okay, so now at -pi over 6, okay, I might have to extend it to the other side because I don't have like, you know, like that much of the space in here. But here, let me extend it right here. Okay, so this is my y-axis, this is my x-axis. Okay, so this is like pi, as you can see, right? So then in the middle of them, we're gonna have like pi over 2, but unfortunately, we don't even have pi over 2, right? So what we're gonna do is that pi over 6 is 30, right? And 30 is like a third of 90. So I'm gonna like cut this one in like 3 parts. And then if you notice, the 12s in here is actually like a half of 6, right? So then we're gonna have pi over 12 right here. Okay, so just to make it more clear, let me get rid of like all the like things in here. And here, this is my pi over 6 here, and this is my pi over 12 right here. Okay, and I'm gonna do the same thing for the other coordinate. I mean, for the other side, the negative part. So I'm gonna get negative pi over 12 for the orange mark, and I'm gonna get -pi over 6 for the red mark. Okay, and 0 to 0, right? So we have all of them. That's good. And now let's talk about the vertical asymptote. So we're gonna have vertical asymptote in here and here. So that means that we're gonna have like straight line in here, right? Okay. Those are my vertical asymptotes. And now let's talk about the points, right? So we have 3 points. Let's do the center first. 0 and 1. So we have it up here. And now we have -pi over 12 and 5. It is way up here. Let's just imagine that 5 is like somewhere up here. And then lastly we have pi over 12 and -3. Let's just imagine that is somewhere in here. That is -2. So here, let me make it like this. Okay, so last step, we're gonna connect all the points together, and then voila, this is the function y equals to -4 tangent of 3x plus 1. Okay, I'm running out of space in here, but make sure in the test you're gonna label each of these. Okay, like you have to label them all out. Okay, I'm just gonna do like one quick example for you guys. Let's say for the 0, 0, I'm gonna put it in pink. So I have 0.01 in here. It's not 0, 0, my bad. So 0, 1 in here is up here, and I'm gonna put 0, 1 next to it just to label them, right? And then for your job, you have to do the same thing. We have like a point up here, and then it has a coordinate, right? X and Y. And we also have like a point down here. It has coordinates of X and Y in there. And then make sure you label these points as pi over 6 for the vertical asymptotes, and then here you're gonna get -pi over 6. Okay, and that is all you have to do for this page. Okay, for your example, I'm gonna give you guys a cotangent function. So notice is that this is cotangent, right? So we're gonna have like a different 5 y values, and hence the x value and then the y values will change too. But then the procedure will be pretty much the same thing. I even like help you guys with a setup in here, but hopefully you guys will see like how they are set up like that by identify A, W, and B. Okay. But again, if you have any questions on this one, please let me know. Okay. And another thing before I move on is that for this one, let me put it in blue. If you want, of course you can like continue to draw them out, right? Like in the same fashion like this. And again, it's just like sketching, so I'm not gonna ask you guys to be like super specific about like, you know, like the other 2 cycles. But because the question is only asking us about the first cycle, so make sure you read the problem like carefully, okay? Don't do like extra work, okay? I'm just afraid that you guys gonna like waste your time and your energy. That's all, okay? So in here, because we're talking about the first cycle, that means that I only expect to see this like orange graph in here. I'm not gonna expect you guys to draw the 2 blue like branches in here, okay? If you do it, it's fine, but I'm not gonna give you like any extra credit for that, okay? And it's just like wasting your time, okay? So now the last 2 functions, cosecant and secant. Just a heads up, they're gonna have like vertical asymptotes. That's why they are also included in 7.7, and hence, if you notice, they have no amplitude. Okay, because again, if you have the vertical asymptote, technically you're not gonna have any bound, right? And because you don't have a bound, that means you have no amplitude. Okay, and if you notice, these are actually the same word from before, right? But you just have to tell like which one is which. So then this one, let me see, what is this one? This one, is it cosecant or is it secant? Okay, in order to graph the function of the form blah blah, we first graph this. So this in here is about cosecant. Okay, and if you know this is the feature of cotangent, right? Like cosecant and cotangent, they have the same type domain, right? And hence secant and tangent, they must have the same type of domain. This is just like a heads up, just so you guys like know, okay? And I told you before, cotangent and cosecant, they start with a C, so it's kind of like an easy way to remember these. And notice that in here, cosecant, it will pass through the origin, okay? So even though I told you guys that cosine, okay, here, let me write in here, cosine and cotangent, they will miss out the origin. Here, actually, you know what, let me put in like, you know, like another color so that you guys can see it better. Let me use blue in here. So it misses the origin. Like the last time we talked about, I told you guys that it's about like cosine and cotangent, right? And if you have something through the origin, they must be something about sine or tangent, right? So watch out that like the red and the blue kind of like code in here, they have similar like domain, but then yet they have like different features in here, okay? So watch out for them, okay? Make sure you can tell the difference between like all the 6 functions in here, okay? And the reason why cosecant will pass through this the origin is because cosecant, this one in here, let me change the color again to red. Cosecant is the flip of sine, right? That's why they have like the similar feature between cosecant and sine, okay? So technically, in order to graph cosecant, technically we only have to draw the graph of sine, and after that we flip it, okay? So if you notice, the graph of sine is gonna look like this. I'm gonna go fast because I know what it looks like already. So 0, 0, and then 1 up here, and then, okay, I'll make a bad one. So here, let me make the points out first. So 0, 0, and then up 1, and back to 0, down to -1, and then back to 0, right? So I'm gonna get something like this. And again, I can extend it to both sides, so it's gonna go like this, and so on, right? And this is like sine, right? It's just sine. And now let me tell you guys how to draw the graph of cosecant. Well, we're gonna flip them. That's how we do. So in here we have like a U shape, right? Here, let me just draw it first, and I'm gonna tell you what's going on. So in here we're gonna have a U shape in here, and I'm gonna make a U shape in there, U shape in here, U shape in here, U shape in here. Okay, that's a bad U shape. And another U shape in here, okay? And what happens between each of the pink like steps in here, right? We're gonna have a vertical asymptotes in there, like I promised you guys before. And why is that so? If you know this, these values right here, let me put it in blue, they have the y values at 0, right? So after you flip them, originally when you just have 0, after you flip them, you're gonna get 1 over 0, which is undefined, right? And that's why we're gonna have a vertical asymptote. Okay, so first of all, draw the graph of sine and then make a U shape wherever you have like, you know, a parabola, and then whatever like gap you have in between, you just have to draw the vertical asymptotes, and then we call it the graph of cosecant. Okay, so here, let me just erase this mark, and instead I'm gonna put this one in red because this one a red function, I mean red graph, and then the pink one, it is the graph of cosecant. Okay, here if you want to like get everything down like that. Okay, so let's talk about like the old features like we had before. Special feature is like a jaw of teeth. If you know this, it's like, you know, like this is your upper jaw, orange, these are your upper jaws, and then these are your like lower jaws. Okay, and then it passes through the origin. If you notice, wait, does it? I will like make an announcement while passing through the origin, but I guess this is not important. So for right now, you can just ignore that one. I think probably I meant like the vertical of it, like the vertical asymptote of it, like will pass through the origin, not the graph itself, because the graph, if you can see, there's no way that will like pass through the origin unless you like lower it down or like, you know, like move it like left or right. But for right now, don't worry about the word through the origin. Okay, and what happens in here is that one cycle of it is like this. Let me put it in, I don't know, brown. One cycle of it is like this. Okay, and the next cycle is gonna go like this. And if you notice, the gap are like one cycle is going from, what is it, negative pi all the way to pi, right? And it's 2 pi. So then the period of cosecant and secant is 2 pi, just like sine, cosine. And if you want to think about it, well, they are actually like the flip of sine, cosine, right? So they should have like similar feature to sine, cosine. That's why they also have the period of 2 pi. Okay, and what else? We have a max, we have a min, and also the midline or like vertical asymptotes if you want to refer them. So maximum, we gonna have this one in here, this one in here, and this one in here. They're all the maximum, right? So in the first cycle, it is at pi over 2 to negative 1. Okay, and you're gonna ask me like, well, this is actually not the first cycle, right? Wait, let me backtrack a little bit. Okay, here, I just realized that I was telling you guys something wrong. Okay, let me use I don't know, green for the maximum, and here let me use purple for the minimum. These are actually the minimum, not the maximum, but these are actually the minimum, and then the green ones are actually the maximum. And why is that so? Because like in each of these like U shape in here, the green points in here are like the highest point, right? And in each of the like the U shape here, each of these are actually the minimum, right? Because the lowest point in each of the jaw that you have in there, that's why they are like maximum and minimum. Okay, I get confused with them a lot. That's why I don't like secant and cosecant. And I don't think I'm gonna ask you guys to like draw out the graph of cosecant or secant in a test. But yeah, it's just like that's the way to think about it. Okay, and then in the first cycle, we have to go from, what is it, from 0 to 2 pi. So let me take out this cycle in here. And honestly, each of the cycle in here, you can define it in your own way, just like me. I personally like it from going like from negative pi to pi because it has like the symmetry. But if you don't want it, if you want to stick with a problem like this one, you can get the cycle of, you know, 0 to 2 pi, just like this case. So then this one in here will be the first cycle of it. Okay, and hence within this picture, we're gonna have this point here as the minimum, and this point here as a maximum, right here and right here. Okay, but usually you're gonna have like 5 points, right? So what happens here are 3 points. Well, these are all like the midline points, right? That's why I call them the midline points. But in here, because they are in the midline, they're also in the positions of the asymptotes, if you notice. That's why I put like slash in here, VAs, vertical asymptotes, for each of the 3 points in here. Okay, so same thing will happen with secant. So here, let me draw the original one in, I don't know, what did I draw before? Okay, let me put it in red for cosine. Okay, so let's draw it out, right? So I know that cosine has like 1 up here, and then this one is 0, back to -1, 0, and back to 1. So it's gonna be something like this. Okay, and if you want, you can extend it to both sides just like this. Okay, and then let's talk about the graph of secant. Secant, we're gonna flip them pretty much. So secant in here, how do we get it? Okay, that is not like a good mark. Secant, how do we get it? Well, we're gonna flip them. So we have a U shape in here. So we flip them, flip them, and also flip them. And in here, this one is not like finished, but yeah. And then in between the like the draws in here, we're gonna get the vertical asymptotes. Okay. And again, my pictures are like, you know, like not that good looking, but if you notice, there are pictures of cosecant and secant in the textbook. So if you want, you can look them up, or you can even like Google them online. There are like plenty of them to check out online. They are much more prettier than this. Okay, so that's the graph of them. And then let's talk about like the first cycle in here. So let me put it in, I don't know, like brow again to mark out the cycle. So we're gonna have the cycle from 0 to 2 pi, which is right here. Okay, so in here, we're gonna have 1 max, 2 min. Here, let me put the max in blue again. So the max, what are they? We're gonna have this one, the max, right? Because in this like draw in here, that point is like the highest point, right? And as for the minimum, we're gonna get I don't know, in pink, I mean purple. So I'm gonna get this one in minimum and this one in minimum, right? Because they are still within the brow cycle in here, right? And again, like in here, we have like these 2 draws. The pink points in here are actually like the lowest point in the draws, right? That's why they become the minimums. Okay, and that are like 3 points already, right? So what happens to the other 2 points? Well, again, they are still like the midlines, and if you want, I can draw like the midlines in here. And same thing goes for this one if you want me to draw like the midline. Okay, so then we're gonna have like 1 point here and 1 point here, but unfortunately okay, let me use like blue for, you know, like just color code. This one and this one in here, they are on the midline, and hence they also on the vertical asymptotes. That's why I put them together under like midline / vertical asymptotes. Okay, and the last thing I haven't talked about is the range, right? So in here, as you can see, it covers like pretty much all values, right? But except for, you know, like within -1 and 1. So here, let me put like correction on here really quick. But before that, let me get like some of these out of paper so that I have like more space to talk to you guys. Okay, that's good enough. Alright, so let's talk about okay, let me put it in green to catch your attention again. So the range of thing is actually not all real numbers. It's all real numbers, but like bigger than 1 and smaller than -1. Okay, so you can say that the range in here goes from -infinity all the way to -1 exclusively, and this one is like U for like union notation, and then you have to pick up from 1 and then keep going to like infinity. Okay, so here, let me put it properly down here for the range. It's gonna be the same thing from -infinity to -1, and then connect to it from 1 to infinity. Okay, why is that so? If you know this, we don't have anything between, right? So here, let me like clean this up so then you can actually see the functions of cosecant in here. Let me also put it in pink again. So if you remember, it's gonna look like this. It's gonna look like this. Okay, it should be more open, like that. And then here's gonna look like this. And in here is gonna look like this, and then so on. Wait, this one is actually have to move down a little bit because that's like where the psi function like end up have. And then I told you we're gonna have like some vertical asymptotes. So with that, a psi function, if you like draw it like by itself, it's gonna look like this, right? And here you're also gonna have like a vertical asymptote, right? And then if you notice, on the y-axis in here, it covers everything, right? Like you can extend it to both sides, like up and down, but then you cannot have anything in between -1 and 1 because they are actually the places of sine and cosine functions, right? So here, let me put it in green. There's nothing in here, right? That means that you cannot have anything in between -1 and 1. And actually, this one is a bad light drawing, so let me draw it again. Like this. Okay? And same goes for this one. If you notice, for secant also, there's nothing in between -1 and 1 because that's the place for cosine, right? That's why it ends up having the same range as this one. It can take any y value except for all numbers that's between -1 and 1. Okay? And just a heads up, if I ask you in the future, is -1 a part of the range of cosecant or secant function, you will tell me the answer is no, okay? Because if you notice, these are like in parentheses. It means that we don't have the value of -1 and 1, okay? And let's talk about how do we actually apply it into like drawing them, into like graphing them, okay? So here for my example, I have this like function right there, and instead of like getting a table for like a new table for cosecant or secant, I'm gonna use a flip of them. So for cosecant, I know that the flip of them is sine, so I'm gonna first draw the function or graph the function y equals to, you know what, let me put it in red actually for like color code. So I'm gonna use red as the original function, and then pink is the actual function or like the final answer. Okay, so here, let me mark this one in, I don't know, pink. So then later I'm gonna draw it in pink. Okay, that's a bad mark. There we go. And then let me draw, or let me write out its reciprocal. Y equals to -2. The flip of cosecant is sine, right? Of x, and then -1/4. And let me put this one in like red highlight, just so you know, like color code. So if you notice, the only thing that's different between like my pink highlight and my red highlight is the function itself, right? Like in the pink one we have cosecant, in the red one we have sine, but all the numbers are the same, okay? So now what we're gonna do is that we're gonna use this table in here for the psi function. So let me put everything in red because these are all for the psi function, okay? So if you remember, for the psi functions, we're gonna have like the 4 quadrant angles, and the y values of them are also from the, you know, like the 5 points of the quadrant angles. And from here you're gonna identify a, omega, and b, just like the old game, right? So my a in here is -2. My omega in here, well, I don't have my omega, or I can put like just 1 for my omega. And because they like no omega, I have no new x. Okay, so new x, no, we're not gonna have any new x. So that's why in my table, if you notice, there's no new x column, okay? And for b, it's like the thing after the psi of x. So in this case, b is -1/4, okay? And I stick with the rules before, since a and b are for y part, I'm gonna like multiply a and I'm gonna add b, right? So I end up having this formula here to find my new y's. So then let's do 0 first. 0 times -2, that is -2 minus 1, -1/4. Let me grab my calculator really quick. Sorry for the noise. Oh, actually, I'm so dumb. This one is actually -1/4, right? Because 0 times anything would be just 0. Okay, and then 1 times -2, so I have -2 in here, times 1, and then minus 1/4. If you want, you can pull out a calculator and do it with me right now. And I get -9/4, right? And then here, back to 0, so I'm just going to copy and paste this value as -1/4. And if you know this one is back to 0 again, so it's also -1/4, right? But this one, like the middle one in here, is -1, right? So watch out for that. You cannot like just copy and paste it because it's not 1, right? So it's going to give you a different answer. And in this case, it's going to be 7/4, okay? And as for the new point here, because we don't have any new x's, right? So I'm going to use my old x in here for each of them. And if you wonder, these are like my open parentheses, okay? So I'm going to have like 0 in here, pi/2 in here, pi, 3pi/2, and lastly, 2pi, okay? And I'm going to go ahead and copy all the y values in here really quick. And then back to -1/4, and then 7/4, and then back to -1/4 again. Okay, so now that I have the 5 points, let me draw them, right? Like, let me graph them out, right? So 0 and -1/4, I'm going to get something like in here. Okay, and then pi/2 and -9/4. So -9/4, if you want to estimate it into the calculator, it is like 2.25 in negative, right? So pi/2 is in the middle, pi and 0. -2.25 is like right here. I'm trying to lower it a little bit. Well, good enough. Okay, and -1/4 in here with pi, so it's like right here. And then this one, if you put it into the calculator, 7pi/4, it is approximately 1.75, right? So at 3pi/2, I'm gonna get something that's like almost 2, but not 2, which is right here. Lower, a little bit lower. Right there. Okay, perfect. And then at 2pi, get back to this -1/4, right? I'm gonna connect them if you want to, but because I already kind of like see the shape of it, so I'm not gonna connect them because I don't want to confuse you guys. And I'm gonna jump directly to draw the functions of cosecant, right? Because we have a U shape in here, that means we're gonna get some U shape up here. So let me draw it like this. U shape up here again, and then in between I'm gonna get my vertical asymptotes. And that's all we have to do, okay? And make sure to do me a favor in the test or in the like quizzes, make sure you label them, right? So first of all, this function is y equals to -2 cosecant CSC of x minus 1/4, okay? And second of all, like all the points in here, make sure you label them correctly. So this point right here, it is 2pi and -1/4. And this point right here is 0 and -1/4, right? And then so on and so forth, okay? And then all of these are actually just copy and paste like all the information from the table, right? So that's like the easy part. But make sure you don't forget them because I'm gonna like mark you off if you forget them, okay? And for your part, I'm gonna ask you guys to do secant. Same rule, right? Like the same x and y values. I mean, same x but different y values. Okay, that's something to keep in mind. And again, if you have any questions, let me know, okay? Because your problem is harder than me in the sense that you have like new x. Okay, so you have to do the calculations for both x and y, okay, to get the points. Okay, and let's move on. Okay, here's a summary, okay? Like there's no work in here, there's nothing you have to turn in for this page, but I just want to put them like together as like amplitude, vertical asymptotes, domain range for each of the 6 in here. This one is a summary. I would recommend, like highly recommend you guys to print this page out, at least this page, because it's like really like necessary for the multiple choice questions you have in the test or in the quizzes, okay? And in here, I think I have them correctly for the range. Okay, so here, let me put it in green again. For cosecant and secant, you can have anything that less than -1 and greater than 1, okay? But you cannot have anything in between, okay? So, the last page. This one is just my tips because I find it like interesting, so that's why I put it there. If you want to like remember like these functions, like the graphs of these functions, you can like dance to them, right? For like sine, cosine, tangent, and cotangent. And if you remember, this guy in here is like, you know, like linear equation, like a line, right? and then parabola for like x squared, and then the V shape for, you know, absolute value, and then this one like, you know, like a curve, a C shape for square root value, and then circle for this guy in here, and then many more, right? And then this guy is just, you know, like me. But yeah, if you have any questions on this one, please let me know, okay? Thank you and have a great day. Thank you for your listening. Bye bye.